Okay, now let's see how we can solve inequalities graphically. All right, so I've put the graphs on, and I didn't really give you the equation, but if I gave you the equation, you could just go into Desmos and graph it. But so here we are graphing it, and I want to know where the function is equal to -2. Where is the function equal to -2? Okay, so I go to -2, and I look at this right here. And I see, right here. Aha, so what are my x values? Well, go up to the x-axis and you see it's 1 and -1. Then they want to know, okay, where is the function less than -2? And that's going to be right here, less than -2. So you go up to the x-axis, and you see the -1 and 1, but we want everything between -1 and 1. So we use interval notation. So we want all the numbers -1, -1, all these right in here. Okay, and then the third one is, where is the function greater than -2? And that is this. It's all up here, all of this. So we go to the x-axis. And I've made a mess of it, so I'm going to just take that off. And we look at the x-axis and we say, oh, it's right here. All those x values and all those x values. Now, how do I say that? Okay, -infinity to -1 union 1 to positive infinity. And there we go. So see the function, I wonder if I can do it. So it's above the x-axis here, or not the x-axis, above -2. Okay, let's see this one. Okay, remember you can always pause the video and try this ahead of me. So this one I want to relate it to 0. So if the function is equal to 0, then what are my x values? Well, here's where x is equal to 0. So we're going to talk about 3 and 1. So those are my benchmarks, okay? So less than is either going to be between those or on the other side of those, okay? So let's do, this one says less than or greater than, less than or equal to. That means I want to keep the 1 and the 3, and you can see that it's actually in between them because the parabola is less than right there. So I want in between 1 and 3 using interval notation. And then greater than is going to be the outskirts. It's going to be out here and out here. And on my x-axis, it's going to be out here and out here. So that's going to be -infinity all the way to 1, and then start at 3 and go to infinity. All right, let's do one more. All right. The question is, where is the function less than or equal to 3? Well, first I want to find out where it's equal to 3. Okay, that's the first thing you do. So here's 3. This is where the function would equal 3. So that's at this point and this point. So my key points are -2 on the x-axis and 0. So less than 3 is either going to be between those two or on the outskirts of those two. So hopefully you can see that the function is less than 3 right here and right here, which means I'm going to take the outskirts of my x coordinates. Okay, so it was from 0, -2 and 0 are my keys. So it's going to be -infinity to -2 and 0 to infinity. And oops, I made a big mistake because it says equal to. So I have to have an equal to on those two lines because I want -2 and I want 0. Okay, now I've just got to say, if it would have said f of x is greater than 3, then I would have want in between the -2 and the 0, and I would have given them that. Okay, so this problem is there. All right, now let's finish up with a little bit more complicated graphs. Now, I graphed this and I put in the parabola, as you can see, is negative x squared minus 3. And that's one of the functions. Sorry, that's not right. Yeah, there we go. So it's negative x squared minus 3.5x plus 2. That is an upside down parabola. And the other is, where do we want it to be compared to is where y equals 2. And so that's the red line right here, y equals 2. Okay, so first of all, what are the points of intersection? That's the first thing you find. Oh boy, that one's like right in the middle of everything. So I'm going to say that's negative 1, negative 2, negative 3.5. Yeah, these are points. Negative 3.5, and I went up to 1.5. Okay, these are points of intersection. And the other one is going to be 0, 1.5. Okay, so the 0, the x coordinates of my point of intersection are going to be my landmarks. So now, where is it equal to 2? It's equal to 2 where x equals negative 3.5 and x equals 0. Okay, so where x is 0, it's equal to 2, negative 3.5 equal to 2. Okay, the next one is going to be just a little smaller. Greater than 2. So where is that parabola greater than 2? And that's going to be here. So we're going to go down to our x-axis, and we're going to be in between my two key points. So it's going to be in between negative 3.5 and 0. And then let's get a different color and do less than or equal to 2, and that's going to be these guys. So that's going to be on the outskirts of my two key points. So I'm going to start, oops, we don't want a great big old marker. So I'm going to start with negative infinity and go all the way to negative 3.5. Oops, it's equal to, so I'm going to have to make that a bracket union. And then, so that's right here. So that's negative infinity to negative 3.5. And then I want to go from 0 all the way to infinity. So I do want to include 0 to infinity. Okay. Let's try another one. Okay. So this one's a little bit different. It's got two functions. What are the points of intersection, first of all? Okay, so here's 1 point and here's 1 point. So I'm going to say the points of intersection are at 1, 2, 3, 4, 5, 6, up 1, 2, 3. And the other point of intersection is going to be negative 1, negative 2, negative 3, down to negative 1, 2, 3, 4, 5, 6. Okay, so the x-coordinate of those points of intersection are going to be my benchmarks. Where is, oops, you don't want that. You want some nice see-throughs. Here we go. Solve, where is this parabola? How can I tell it's a parabola? It's x squared, and it's got a negative, so it's the upside down parabola. Where is that equal to this line, x minus 3? Okay, so you need to be looking at this line is x minus 3, and this parabola is negative 13x squared plus 2x plus 3. And I want to know where they're equal. Well, those are going to be the points of intersection, but I just want the x coordinates. So the answer to that will be x equals negative 3 and x equals 6. Okay, now, next question is, where is that parabola less than or equal to? that line? Where is the parabola less than or equal to the line? So it's clearly not up here. If you see here, the parabola is above the line. But boy, if you keep going this way and this way, the parabola is definitely below the line. So we want to take our key points, which are at -3 and 6. Those are our intersections. And we don't want in between those, because that's where it's about. We want these points and these points are where the parabola is less than the line. So that's going to be from -infinity to -3, and then from 6 to infinity. Now they don't have it, but I want to know where is, so I'm going to solve -13x squared plus 2x plus 3. Where is it greater than x minus 3? Where's the parabola above the line? And that's going to be in between the two intersection points. So that's going to be in between where x equals -3 and +6. Okay, so that would be my final question that I added right here. Okay, I'm going to give you one strange one because they do exist. Okay, so oh, there it is. They did have it on there. Okay, sorry, that went with the problem above. Okay, so then you guys probably had it on your notes. Okay, so let's look at this one. This is a bit of a strange graph because, well, we'll just see. Okay, so what are the points of intersection? First of all, there's only one point of intersection. That's what's kind of strange about it. So the point of intersection is at 0, 0. All right, now here's the question. Where is the graph equal? Now, this is to the third power. That's the blue one. That is this x cubed plus x is the cubed one. And because we know that this 16x squared is our parabola. Okay, so keep in mind, where are they equal? Yeah, that's where x equals 0. We can do that one. Where is the x cubed less than? Where is it below that? Okay, well, that would be right here. You see how it's below the parabola? So I want to go up to the x-axis and take all of these x coordinates. So that's going to be from -infinity to 0. And that's open because there's no equal sign. And then the last part would be, where is the parabola, or the cubic, they call it, the x cubed plus x. Where is it above the parabola? And that's going to be right here. And that's going to be all of these x coordinates. So that's going to be from 0 to infinity. Okay, so that was a little strange, but all right. So see how you do on this section.